Okay, so welcome back to another video. Here's a trigonometric integral. So what we have is from 0 to pi over 4 of the square root of secant of 2x subtract 1 divided by tangent x dx. So actually, I really like this one because a lot of the stuff that we're actually going to be dealing with in terms of the process is that it's not so much of the calculus techniques, but rather it's dealing with a lot of algebra that I think makes every sort of like each step, like the transition, really like nice and interesting. So as of course I said that we're actually be using a lot of trigonometric properties and of course using some algebra. So but there will be some calculus involved later down the line. Eventually we will actually get to the point of where we will have to integrate our given function. But nothing much that needs to be said. So yeah, with that, why don't we actually just jump right in. So I think it's worth noting that before I do anything, let's actually start with a nice identity that we know that, of course, secant of 2x is, of course, the same thing as 1 divided by cosine of 2x. So we just want to, of course, keep that in mind. So let's actually now start with the integral that we're given with. So from 0 to pi over 4, then the square root of secant of 2x, subtract 1. And then what I'm going to do here is I'm actually going to multiply and divide a square root of cosine of 2x. So that's from both the numerator and denominator, just like so. And then follow up with, of course, just dx. Then what that will do is that, of course, if I just multiply the square root to everything here, so I actually write parentheses over here. So what I'll do is that the square roots will cancel, so then it will be secant 2x times cosine 2x, which of course we use this identity, so that means that's just going to cancel out to simply just become 1. So I'll just reduce that down to just 1. 1 subtract the square root of cosine of 2x, and then divided by tangent x, and then multiply by the square root of cosine of 2x, and then dx. Okay, so now what we're going to do here next is, of course, we still have the square root that we're going to deal with. So why don't we actually instead now multiply by the conjugate of its numerator. So that means we have a minus associated with, so that means I'll just write this as a plus. So then now we have the integrals from 0 to pi over 4 of 1 minus the square root of cosine of 2x multiplied by its conjugate, so 1 plus the square root of cosine 2x, and then that's going to be same thing on the denominator, so tangent x times cosine of 2x, then multiply with 1 plus the square root of cosine 2x, follow up with dx. So then after multiplying with the conjugate, so that means obviously you can see on the top is actually just a difference of squares. So then now we have 0 to pi over 4 of just 1 minus cosine of 2x. And then being divided by is tangent x. So the denominator still stays the same. So cosine of 2x. And then multiply with 1 plus the square root of cosine of 2x. And then follow up with dx. Okay, so now next thing what I'm going to do is that now, as you notice, 1 minus cosine of 2x, it actually has a nice trigonometric identity. We can actually substitute to write this as 2 sine squared of x. And then tangent x is the same thing as sine divided by cosine of x. So pretty much it's on the denominator. So I'll just flip its reciprocal. So then that will become 2 sine squared of x and then times cosine of x. Then we divide this by sine of x. And then the square root of cosine of 2x multiplied by the conjugate, so 1 plus the square root of cosine of 2x, and then dx. And then continuing forward, that we know that the signs are going to cancel from both the numerator and denominator, so that's just left with 2 sine of x cosine of x, which of course we can substitute that identity as the same thing written as sine of 2x. And then under the denominator, it's still, of course, still just going to be the same thing, so cosine of 2x, and then multiply by 1 plus the square root of cosine of 2x. Okay, and then follow up with dx. Okay, now I'm actually going to get a little clever with this one. This one's actually pretty interesting to do with here. I'm actually going to multiply and divide a 1, but by manipulating this, what I'll do is that I'm actually going to take it into account with the negative. So what that will do is that I have a negative 1/2 outside of our function or our integral. So negative 1/2 from 0 to pi over 4, and then multiply by a negative 2 sine of 2x, and then of course being still divided by the square root of cosine of 2x, and then multiplied with 1 plus the square root of cosine of 2x, and then followed up with dx. Okay, so that's a lot of trigonometric substitutions, all that stuff. Now this is where we actually can get into the calculus. So we're gonna let u equals cosine of 2x. So of course du is then just gonna simply just equal -2 times sine of 2x, and would you look at that, we can already tell that something's definitely going to be canceled out once we perform the substitution. So then that just leaves us with -1/2 multiplied by the integral of, so of course we change our bounds, so this is actually just going to be 0 on the top and 1 on the bottom of du, and then divided by the square root of u multiplied by 1 plus the square root of u. Okay. And then, so now we just change things up. So what I'll do is, I'll actually put back the 1/2 outside, and then we're gonna switch our bounds, and then the negative's gonna cancel. So then this is just gonna be 1/0 of 1/2 u to the power -1/2. That's just coming from over here, just rewriting in terms of the fraction, and then multiply by 1 plus the square root of u, and then du. Then we can actually yet again perform yet another u sub, but we'll call this t. We'll let t equals 1 plus the square root of u, and then so dt is going to equal 1 divided by 2 times the square root of u, which then du, which of course that's still going to be the same thing in terms of we just write this with the radical. So that's just going to cancel, and then we're just left with, so change our bounds yet again, we're going to have that this is going to be from 1 to 2 of 1 divided by t, and then dt, which of course this is simply just going to be the natural log of t from 1 to 2. Put in 1 is going to be 0, of course, and so therefore plug in 2. The final answer of this trigonometric integral we just dealt with is simply just ln of 2. Something that's a simple answer like that with all this, a majority of the work that we were doing with, it's just, you know, trig identities, algebra, and a little bit of calculus from here and there, which follows with that. So yeah, that's pretty cool if you ask me.